All right, you crazy kids, here's your lecture on significant figures. So, all the values that we use in our calculations in chemistry come from measurements. And depending upon how you measured that value, you have a level of significance that you can use in your calculations. So, we have to figure out what values are significant and what values are not significant. And it all depends on how you write them. Our first example, we have, in orange here, 200 grams versus 200 grams. And one of these I've used a decimal place, the other one I did not. The one I used a decimal place, that means I've measured to that degree. I know that these are zeros, therefore they are significant. So I would have a total of 3 sig figs because all non-zeros are also significant. I've measured to that amount. So that's 200 grams, and I'm confident that that zero is actually a zero. So it's significant. On the other side of the equation, I don't have a decimal place. That means these are approximations. I don't really know if it's a zero or not because I did not place that decimal place. I know that this is a 2, but I don't know if these are actually zeros. Because of that, they are not significant. So I only have 1 sig fig here. In reality, that's about 200 grams right here. I don't know if those zeros are there. It's an approximation. It could be 188 grams. It could be 222 grams. I don't know. It's a rounded value because there's no decimal place. Over here, with that decimal, it is a measured amount, so I can reliably say that those zeros are truly zeros. This example here shows a zero in between non-zeros. Zeros in between non-zeros are significant. They are measured. So all 3 of these are significant, and I would have 3 sig figs there. It gets a little tricky if we look over here on whether or not zeros are significant after a decimal place or before a decimal place. Before a decimal place, this 0 is definitely a placeholder. It's something that's just there. You'll often hear people pronounce this or say this as 0.0020, or sometimes they just say 0.0020 kilograms. So that's definitely a placeholder. However, these ones we don't really know about. I'm letting you know that they are placeholders. They do not count. Those zeros are due to the unit that you're using. In this case, I'm using kilograms. If I were to convert this from kilograms to grams, and we know that 1 kilogram is 1,000 grams, my units for kilograms disappear, and this turns into 2.0 grams. These zeros have magically disappeared because they were placeholders due to the unit that you were using. So, zeros before a non-zero after a decimal place do not count. They are not significant. Zeros after a non-zero after a decimal place do count. They are significant. In this example here, I have a total of 2 sig figs, the non-zero and the 0 that follows the non-zero. And I still have 2 sig figs here because I shouldn't change the number of significance as I've changed the unit. So that 0 that follows the decimal place is also significant right here. If you want to test your knowledge with this problem right here of how many sig figs we have, I'll give you a second. Count them all up. Significant, 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 significant. And these are placeholders. So we have a total of 1, 2, 3, 4, 5 sig figs. So hopefully those examples will lead you to the ability to count how many sig figs you have. And it's important to count the number of sig figs because when we do calculation, I have to report the correct number of sig figs in my answer. If I multiply and divide in my calculation, you can only use the least number in the problem of significance. For this example, I have here 50 divided by 4.00 milliliters. Here I have 2 sig figs because of the decimal place. Here I have 3 sig figs because zeros that follow a decimal place after a non-zero count. When I divide this, I get 12.5 grams per milliliter. My units stay. Looks like that's a calculation in density. However, I can't report 12.5. Because I only had 2 sig figs here, I can only report 2 sig figs in my answer. So my 12.5 turns into 13 grams per milliliter. And that's how I'd expect you guys to report it. So that's the rule for multiplication and division. It's the least number of sig figs of any value that you're either multiplying or dividing in your calculation. For an addition and subtraction, it's a little bit different. It's now your level of significance that deems the level of significance of your answer. What I mean by that is here, we've measured 2 places past the decimal, and here, I haven't measured anything past the decimal. All I have is a whole number, 9 milliliters. When I add these two values together, I would get 17.63 milliliters. However, I can't report the 6 and the 3. I don't know what values are really here. That could change that 6 and the 3. So I can only report to the level of known significance, or my whole value here. So these numbers, the 6 and the 3, cannot be reported because, once again, I don't know what the values are on that 9 milliliters. So I can't report that in my answer. My answer is going to turn into 18 milliliters. It's not total number like it was multiplication and division, right? Because I have 3 sig fig here, I have 1 sig fig here. It's level of significance when you add and subtract. So my answer of 18 milliliters, hopefully it makes sense to you. We'll put it in green. And that's how you do sig figs: multiplying, dividing, adding, subtracting, and how do you figure out what things are significant.